Hi everyone, I'm Yichi Zhang from University of Michigan. Welcome to the presentation of our paper on eliciting honest information from others via sequential review. This is joint work with my advisor Grant Schoenberg and my co-author Weijie Su. I guess everyone is pretty familiar with the conference peer review process. So authors submit their paper to the conference assigns those papers to the reviewers, and finally, based on the noisy review, the conference makes the decisions. The issue is that peer review is known to be very noisy. In the famous 2014 NeurIPS experiments, for two independent conference committees, only 50% of their accepted papers are overlapping. Our idea in this paper is to use others' information to assist the conference making better decisions. And furthermore, we want to reduce the review burden, shifting review resources from likely rejected papers to those likely high-quality papers. And finally, we want to incentivize authors themselves to focus more on paper quality over quantity. Thus saying, the authors are incentivized to write fewer papers of higher quality instead of generating a lot of mediocre papers. How can we do this? If we think about this problem a little more, it is actually very challenging. Suppose the conference try to elicit the truthful paper quality information from authors. The issue is that the author is always incentivized to inflate the score. They're gonna say that their papers are perfect, and there's no information. The good news is that we can actually elicit a ranking of paper quality from an author with multiple papers. Let me use this toy example to introduce our idea. We call this the naive sequential review mechanism. Suppose an author has 4 papers, and the reported ranking is from high to low in sequence. We're gonna look at the first paper, the top ranked paper. And if the top ranked paper got rejected, the mechanism will terminate the review process and all the remaining paper will be rejected without review. If the first paper got accepted, it will move to the second paper. If the second paper got accepted, it will move to the third paper until it faces one rejection and terminate the review process. Intuitively, this idea is kind of truthful because suppose an author try to strategically flip the ordering of 2 papers, it's more likely for him to face an earlier termination, which is always bad for the author. Before I move on, let me first emphasize that this idea of eliciting ranking information from author is actually not new. The previous isotonic mechanism can do this while assuming the author's utility is convex with respect to the review score. The issue is that in practice, a lot of cases that authors' utility are not convex with respect to the review score. For example, when they try to maximize the expected number of papers that are accepted. Towards this issue, we propose a sequential review mechanism that utilizes a slightly different model. But what we can do is to elicit the truthful ranking information while assuming author's utility is increasing with respect to the paper quality, conditioned on those papers being accepted. We'll come back to this soon. This table summarizes the difference between these two mechanisms. So first, we can both help the conference make better decisions, but only our mechanism can reduce the review burden and incentivize others to write fewer papers of higher quality. About the model, suppose one author has n papers, and the quality of these papers are ordered from Q1 to Qn decreasingly. This is the primary information to the author. The review score is equal to the true quality Qi plus an additive noise term, epsilon, which is IID across all the papers. The acceptance probability is a function of review score Ri, and the author reported ranking, which is permutation pi across of all n papers. We are truth telling pi star I equal to I for all the paper I. Author's utility is equal to the summation of all the accepted papers reward, where the reward function UA is increasing with respect to the true quality Q. For example, if UA is equal to 1 for all Q, then the author is just maximizing the expected number of papers that are accepted. We care about truthful mechanisms, so that means when the author reported truthful ranking pi star, its utility is maximized compared with all other possible ranking high. Now we are ready to present our sequential review mechanism framework. Recall the previously introduced naive mechanism. The problem there is that it is too harsh. Suppose an author has a lot of good papers that are worth accepting. The naive mechanism, unfortunately, is gonna likely reject a big portion of it. Our idea is to generalize this idea to a larger set of mechanisms that the designer can choose from. We call this the sequential review mechanism framework. Within the framework, we propose two intuitive examples that can be potentially used in practice. The first one, we call this the memoryless coin flip mechanism. So what it's doing is that instead of terminate the review process immediately while facing one rejection, it's gonna give the author a second chance by flip a coin, where the probability of continuing review the second paper depends on the review score. By the way, this takes the previously presented naive mechanism as a special case. The second example, we call this the credit pool mechanism. So what it's doing is that we're gonna add some credits to a pool if the author's paper got accepted. We're gonna remove some credits from the pool if the author's paper got rejected, and terminate the review process immediately if the pool is empty. The next question is, when are those mechanisms truthful? So we identify a sufficient condition for this sequential mechanism to be truthful so that we guarantee everything within this red circle is truthful. Unfortunately, we don't have time to introduce the details. If you're interested, please refer to our paper. Now we have some time to introduce one property of the sequential review mechanism about the review burden. Let me first introduce these two dimensions that the conference may care about. The first dimension is the conference utility, which is defined by the summation of all the accepted papers' qualities in expectation. The second dimension is the review burden, which is equal to the expected number of papers that are reviewed by the mechanism. Ideally, we want the review burden to be small and the conference utility to be large. We're going to compare our mechanism with the baseline. We call this a threshold parallel review mechanism. It's called parallel because all papers are simultaneously reviewed, which is kind of like what we are doing right now in real life. The threshold implementation means that if the review score Ri is larger than the threshold tau p, it will be accepted. Otherwise, it will be rejected. Very simple. And our method, we're going to go with the threshold sequential review mechanism. So if the author's paper's review score Ri is larger than the acceptance threshold tau a, it will be accepted, and we continue to review the second paper. If the review score is below tau a, but still larger than a lower threshold tau r, we're going to reject the paper, but still continue to review the second one. And lastly, if the review score is just too low, we will reject the paper and terminate the review process. We care about the relative review burden, which is the ratio between the review burden of the sequential mechanism and the review burden of the parallel mechanism, which is always equal to n in this case. Again, we assume there's only one author with n papers. So this relative review burden is conditioned on two mechanisms achieving the same conference utility. So conditioned on the same conference utility, how much review burden can be saved while using the sequential mechanism. We optimize the relative review burden under each parameter setting under this double Gaussian model. Our main observation here is that the sequential mechanism is more powerful in comparison in the following three cases. First, when n is large, that's when the author has a lot of papers and is providing more information. And when mu-q is small, that's when the author's papers are likely to be bad and going to be rejected anyhow. And then lastly, when sigma r is large, that's when the review is very noisy. We further apply our sequential review mechanism in a more complicated model, which is estimated by the ICLR dataset. We observed that the relative review burden across all 3 years of test is about 0.8, which means we can save about 20% of review burden while using the sequential review mechanism. This happens even when the majority of the authors only possess 1 or 2 papers. Let me briefly discuss how to implement our mechanism in practice. As I presented our idea, actually I ignored 2 issues. The first is that what if one paper has multiple authors? Our solution is to assign each paper to only one of its authors and solicit ranking information from the selected authors only. This reduces the problem back to a single author case. The second concern is that what about the delay in the review process? This happens because the review of a paper starts only after the previous paper's review is finished. So if an author has a lot of papers, the review process will be significantly delayed. Our solution is that we can actually simultaneously review all the papers, just like what we are doing right now, but we make the decisions in sequence. This again can elicit the truthful ranking from authors, but we no longer can reduce the review burden. In our paper, we have more detailed discussions on how to trade off these 2 dimensions. Let me conclude. So we present a truthful sequential review mechanism framework, which possesses a lot of properties like it is truthful for a more realistic model. It can assist better decisions, reduce review burden, and prioritize the review of likely good papers. And finally, it can incentivize authors to generate fewer papers of higher quality. Again, I skipped a lot of details of our paper. So if you're interested in the topic, please refer to our paper, or you can stop by my poster. Thanks.